Hello friends, in the previous lecture we have discussed spread spectrum with frequency hopping spread spectrum. In today's lecture we discuss spread spectrum with the point direct sequence spread spectrum technique. This technique also expands the bandwidth of the original signal, but this time process is different. In a direct sequence spread spectrum, we replace each data bit from the message with 11 bits using a spreading code. That means each bit is assigned a code of 11 bits that are called chips, where chip rate is 11 times that of the bit rate. As shown in the figure, original signal get modulated with chips generated by the chip generator, and that signal will get spread, that is in the form of spreading signal will get output. Consider the sequence used in wireless LAN as the Barker sequence, where N is nothing but 11 bits. We assume that the original signal and the chip generator use polar NRZ encoding method. As shown in the figure, original signal is having message 101 and spreading code is having 11 bit pattern as the Barker pattern. In this figure, chips and the result of are multiplying the original data by these chips to get spread signal. Here spreading code is 11 chips is having the barcode pattern 10110 111000. If the original signal rate is n, then the data rate of the spread signal is 11 times n. The required bandwidth of the spread signal is 11 times larger than the bandwidth of the original signal. The spread signal can provide privacy if the intruder does not know the code. It can also provide the immunity against interference if each station uses different code. Next is the bandwidth sharing. If we use a spreading code that spreads signals from different stations that cannot be combined and separated, therefore we cannot share a bandwidth. That means some wireless LANs use direct sequence spread spectrum and spread the bandwidth cannot be shared. In another case, if we use a special type of sequence code that allows the combining and separating of spreading signals, at that time we can share the bandwidth. That is, special spreading code allows us to use direct sequence spread spectrum in cellular telephony and share a bandwidth between several users. Advantages of direct sequence spread spectrum. The simple hardware implementation is there for this DSSS. Best noise and anti-jam performance, does not require complex frequency synthesizer as like FHSS, and best discrimination against multi-path. Disadvantages of DSSS: it requires wide band channel with little phase distortion. Its long acquisition time, fast code generator needed in this case. Also face near and far problem. Okay, thank you.